Okay, solve d2y dx squared equals minus 2 over y to the power of 5, given that dy dx equals 1 and y equals 1. So look, what we're going to do first and foremost is we're once again going to change phi into dy dx. This rewrites the full equation as so phi equals dy dx, okay? So lads, the problem is we do what we did last time, okay? What's going to happen is we're going to change this whole thing to we're going to change it to the derivative. We're going to change it to dv dx, okay? Because the second derivative is the derivative of dy dx, because that's what d2y dx squared is. And if we say phi is dy dx, we're going to end up with dv dx. Now dv dx ends up to minus 2 over y to the power of 5. The problem here is, in all the previous questions, we usually have the variable is y, but we don't have any dy's. That's the problem, okay? To fix this problem, we're going to use what's called the chain rule. And the chain rule is basically just, it's just using fractions to get what you're looking for. So for instance, I'm going to put the v up here, I'm going to put the x down here. I need an intermediate value to bridge them together. Because I'm dealing in y's, it's going to be dy. So I'm going to use dv dy dx. Okay, this is known as the chain rule. Okay, so what we're going to get here is that dv dx ends up to be, and we've already discussed that dy dx is v. So it's going to be phi dv dy. So now when I rewrite this full equation, I'm now going to have phi dv dy equals minus 2 over y to the power of 5. My problem has now been solved. I can now integrate as I've done in the last couple of exercises. So what I'm going to get is going to bring the y up here, and I'm going to get v dv equals minus 2 y to the power minus 5. I'm going to change it to a power or an index, and then I'm going to get dy. Next thing I'm going to do is match up my limits. Now remember, keep in mind v is dy dx. So I'm going to go back to the top. V is 1 when y is 1. Match up your limits. V is 1 when y is 1. Use the top letter. Because it's the v, there's a v up there. Because it's the y, there's a y up here. Integrate both sides. I'm going to get a half v squared on the left from v to 1. Okay, and then on the right hand side, I'm going to have to integrate this. Now, when I integrate that, the first thing I know is it's going to be y to the power minus 4, because I have to add on 1 to the power. Now I got to think about what happens when I differentiate it. The minus 4 goes to the front. Okay, so I'm going to need it to be, I still want it to be minus because I want the answer to be minus 2. So I'm going to put a half in front of it. So when I differentiate this, it has to turn into minus 2 y to the power minus 5. When you differentiate that, the 4 goes to the minus 4 goes to the front, multiplies by the half. You take 1 away from the power, and you do get minus 2 y to the power minus 5. So this is the correct integral. Then we get y and 1. Integrate both sides. Now this here is the same thing as 1 over 2 to the power of y over 4. Probably makes it easier to integrate, or easier to put the limits into. This is still a half phi squared phi 1. Now integrate a half phi squared minus a half 1 squared equals 1 over 2y to the 4 minus, it's going to be minus a half because 1 to the power of 4 is still a half. Now the halves on both sides are going to cancel, and what we're going to get is a half phi squared equals 1 over 2y to the power of 4. So there's a problem here. We're going to get rid of the halves, and what we're going to be left with is phi squared equals 1 over y to the 4. Now let's square root both sides. When we square root both sides, what we're going to get is phi equals either 1 over y squared or minus 1 over y squared. One of them works, the other one doesn't. But how do we explain which one it is? Go back to your top. You know that phi equals 1 when y equals 1. That's the rule, that's one of the limits. Phi equals 1 when y equals 1. This will work for this one, because if you plug in y equals 1, you get phi equals 1. However, it doesn't work for this one, because when you put in y equals 1, you're going to get minus of 1. So that means that only the left one is the one that we're going to use.
Minus phi as well.
No, because the whole point is the limit says phi equals 1 when y equals 1. So you only square root one side. Oh, sorry, Garrett, I get what you're saying. You'll get 4 outcomes. But even though you get 4 outcomes, there are 2 sets of 2. They're both the same. Okay? So you are right. And so what we're going to get next is, we know that phi equals 1 over y squared is the correct one. We also know that phi is the y dx. Okay, so phi is the y dx, and that's 1 over y squared. Cross multiply again, bring the dx up and bring the y squared up. We're going to get y squared dy equals dx. We're next going to integrate both sides, but where do we get our limits from? X is the top one, y is the top one. Go back to the front of the question. X equals a third when y equals 1. 1 and a third. Integrate both sides. Y cubed when you integrate 2. Put the third in front of it. And you get y equals, when you integrate this, you're going to get x dx from 1 to a third. Oh, sorry, just x, because the dx disappears when you integrate. Okay, and the third is the limit. Oh, x the other limit. Yeah. Now, what we're going to get there is, we're going to get a third y cubed minus a third 1 cubed equals x minus a third. These two will cancel. We're going to get a third y cubed equals x. Bring up 3. We're going to get y cubed equals a third x. 3x even. And therefore we're going to get y equals the cube root of 3x. Okay, that's the solution to that question, and that is 12f. Now